We are going to show the end-to-end testing of ORAN containerized network functions and OClouds for optimal workload placement and performance. To deploy an ORAN node, it is foreseen the integrators will have to select the vendors for the CNFs from a marketplace specialized at the application level, and the OCloud hardware and software infrastructure from another marketplace specialized on infrastructure providers. To get the best working ORAN solution, exhaustive testing would have to be done on the network functions based on different infrastructures to select the optimal combination. The optimal placement will deliver the best performance and consequently, value. Of all the options tested, measured and compared, the operators would usually have to select not only on performance, but on cost. In order to do that, an ecosystem of software, hardware components and testing tools to determine optimality will have to be developed, including ORAN network functions, OClouds, orchestrators, application testing tools and cloud testing tools. In this demo, we will verify the performance of different OCloud platforms before the deployment of CU and DU to achieve optimal placement. This enables the development of the mentioned ecosystem. First, the Telco Cloud Testing Tool from Vohia will benchmark both OClouds, and then the ANA SMO will deploy the CU and DU on the optimal cloud for each, including the Rabaka testing functions. Finally, both will be tested in optimized environment by Rabaka's test system. Let's see that in detail. First, the two candidate OClouds for deployment are onboarded by the AMCOP SMO. Then a request is made to Touchstone for a benchmark of each OCloud. Lastly, Touchstone executes all the benchmarks and produces a report about the suitability of the clouds for the CNFs. Once the AMCOP SMO gets the information from the reports, it determines that the CU should be deployed on OCloud A, and the DU should be deployed on OCloud B. And then proceeds to deploy them. Once deployed, Rabaka's ABOT system deploys the rest of the testing environment and proceeds with the functionality testing. We'll see how to onboard a cluster to ANA SMO. First, we need to create a registered cluster provider, so for that I'm getting OCloud A. And next cluster provider OCloud B. For each provider, we need to onboard a cluster. Here we introduce the cluster name, which is OCloud A. The corresponding Kuba config file has to be uploaded. So, after OCloud A, the kube config file is uploaded. Now that OCloud A is onboard to SMO, we will onboard a cluster to OCloud B. Again, cluster Kuba config file for OCloud B. Both the clusters are successfully onboard to SMO. Touchstone got a request to benchmark OCloud A and OCloud B. We would start with benchmarking the OCloud A. First, we run the OCloud DU benchmark. While we wait for this test to conclude, we're going to queue the other benchmark. We would queue the benchmark for the CU just after this one. After the testing finishes, we have all the results and we can view the report. After both reports are done, we can select them for comparison. In the report we can see all the results for both benchmarks, and the summary of the scores they got in each test. After that, we benchmark the OCloud B. Again, we first start the benchmark for the DU, and we queue the benchmark for the CU after that. The first one is already running, and you will have to wait for 3 hours until both benchmarks are finished. After finishing both benchmarks, when the benchmark of the CU is finished, we can then go to the reports and download them to compare them. With the results of the benchmarks of OCloud B, we can see that the benchmark for the DU is good enough, but the benchmark for the CU is not good enough, so it would only be able to host a DU. We will see the deployment of CU and DU on their respective OClouds. First, we need to create the services on the SMO side. The first service is for CU. The name is ORAN CU Simulator, and here we give the application name, which is, again, ORAN CU. And here we need to upload the CU Helm charts. So the Helm charts are uploaded and the corresponding override file. With this, the service for CU has been created. Now we will create a service for the DU. The name followed by the application name ORAN-DU. And here once again we need to upload the DU Helm charts and corresponding override file. With this service for the CU and the DU are created. Now we need to create the service instances which indicate where it has to be deployed. The service instance name, which is ORAN CU, and we will select the corresponding cloud, in this case OCloud A. We will select the corresponding cluster where it has to be deployed, which is OCloud A. We'll create the next service instance for DU. And the corresponding cloud, which is OCloud B here, and we give the version. Again here we will select the corresponding cluster where it has to be deployed, which is OCloud B. With this both the service instance are created and we are instantiating, which is nothing but deployment of the CU and the DU on their respective clouds. This is a test written using ABOT to test remote device capability after startup using the ORAN interface. The test consists of steps that are depicted in the graphic in your screen. Once the test finishes, one can review the artifacts, for example the packet capture containing device capability. Moving forward, the user can then also analyze the canned log in order to verify all the steps that were executed. The ABOT Analytics dashboard helps the user understand all the procedures that were executed in the remote device, the scenarios that were executed during the testing, the protocols that were encountered, the failures. The user is presented with mobility KPIs that one can analyze and a storyboard that contains a summary of all the testing that has happened over this period of time. Thank you for your attention. If you want to contact any of the companies featured in this demo, here you have their contact details.